In the previous lesson, we talked about simplification by factoring. So in this lesson, we're going to see two examples that look a little bit more challenging, but what they really stem from is applications of the derivative, which will come up in calculus. So it's important to understand how to use simplifying by factoring to simplify statements that come from our product rule, chain rule, and quotient rule when we're dealing with derivatives in calculus. So this would be an example of one expression that would result after using the product rule and chain rule. So if we have 3y squared times 7 times 2y plus 5 to the 6th times 2 plus 6y times 2y plus 5 to the 7th. So more complicated than what we had before. Our first step is what we want to do is we want to multiply the monomial factors within each group. So we have two groups, remember, separated by that plus. We have this first piece, which is that 3y squared times 7 times 2y plus 5 to the 6th times 2. And then the second piece, which would just be the 6y times 2y plus 5 to the 7th. So simplifying that first group, again, I want to multiply the monomial factors. So I'm looking at the 3y squared times 7 times 2. Well, 3y squared times 7 would just be 21y squared. 21y squared times 2 would be 42y squared. So the first group can simplify to 42y squared. Then we're going to keep the 2y plus 5 to the 6th. In my second group, I only have one monomial factor. I only have that 6y, so we don't have any simplification to do there. I'm going to keep that 6y. And then we have 2y plus 5 to the 7th. Because now we have something that looks a little bit more like what we were dealing with. Because our next step then, in order to do our simplifying by factoring, would be to find our greatest common factor of each group. Well, again, now our group is separated by that middle plus. So I'm looking at the 42y squared times 2y plus 5 to the 6th, and then the 6y times 2y plus 5 to the 7th. So again, we want to find the GCF of each. So first I'm going to look at the 42 and the 6. So 42 and 6, our greatest common factor there would just be 6. Of y squared and y, our greatest common factor would just be y, because remember when we have the same base, we want to take the smaller power. And then we can see that our factor of 2y plus 5 to the 6th and 2y plus 5 to the 7th, that 2y plus 5 is in common, which means that I can take out as a greatest common factor 2y plus 5, and again we're going to take the smaller of the two exponents, which would be the 6. So our greatest common factor of the expression is 6y times 2y plus 5 to the 6th. So now that we found that greatest common factor of 6y times 2y plus 5 to the 6th, our next step would be to actually factor it out. So remember, when we're factoring it out, we are dividing. Now again, you don't need to write this step that I'm showing with the division, but what you do need to remember is that when you divide, you would subtract your exponents. But I am going to show it so that you can see where it came from, but eventually we should be doing this in our heads. So I'm dividing each group by the 6y, 2y plus 5 to the 6th. Same thing with our second group, 6y times 2y plus 5 to the 6th. So remember, we're dividing it out, but that 6y times 2y plus 5 to the 6th is going to be part of our final factored answer. So I'm going to put this on the outside, 6y times 2y plus 5 to the 6th. We don't forget about it. And then after we divide it out, whatever we're left with will go inside the square bracket. So 42 divided by 6 would just be 7. So I'm going to have a 7 over here. Y squared divided by y, subtracting your exponents, 2 minus 1 is 1. So you're just left with a y. So that gives you 7y. 2y plus 5 to the 6th and 2y plus 5 to the 6th would just cancel out completely. So your first group simplifies to just 7y. Then for our second group, 6 divided by 6 would just cancel out. That's just 1. Y divided by y, same thing. Those would just end up canceling out. But then here we have 2y plus 5 to the 7th divided by 2y plus 5 to the 6th. Again, subtract your exponents since they have that common base. So 7 minus 6 is 1. So we're left with 2y plus 5 to the first, which is the same thing as just 2y plus 5. So our second group simplifies to just 2y plus 5. Our last step then would be to simplify the inside. So the 6y times 2y plus 5 to the 6th stays. And then inside we can combine like terms. So 7y plus 2y would be 9y plus 5. And then this would be our factored form. Again, you can use parentheses there instead of square brackets if you like. But that would be our fully factored simplified form. 6y times 2y plus 5 to the 6th times 9y plus 5. So our last example would be a situation that you might experience when you're using the quotient rule and the chain rule when you're when you're finding the derivative in calculus. So it definitely looks more complicated. We have that fraction piece, but we're going to start off the same way, is that we're going to identify and look at our numerator first. And we want to multiply the monomials in each group of the numerator. So in this case, we have a subtraction that is separating our two groups, but we do want to simplify this. So in our first group, we have 3x plus 2 to the 7th times 9 times 5x plus 1 to the 8th times 5. So in multiplying the monomials, I'm talking about multiplying the 9 times the 5, which would give us 45. And then, since those are the only monomials, everything else we can just carry over. So the 3x plus 2 to the 7th and the 5x plus 1 to the 8th. Same idea in our second group. So in our second group, we have 5x plus 1 to the 9th times 7 times 3x plus 2 to the 6th times 3. So again, I'm going to multiply the 7 times the 3 to get 21, and then carry everything through. So 5x plus 1 to the 9th, and then 3x plus 2 to the 6th. Still all over that denominator of 3x plus 2 to the 14th. So our first step is the same, multiply the monomials in each part of the numerator. Now, next step, still the same thing, because the numerators are all our issues are in terms of simplifying for right now. So we want to find the greatest common factor of that numerator. So again, looking at each group, seeing what we can factor out. So first, with our coefficients, that monomial 45 and 21, between 45 and 21, we have our GCF of 3. Then looking at our factors in the parentheses, in my first group I see that I have a 3x plus 2 to the 7th. If I go over to my second group, I see that I have a 3x plus 2 to the 6th. So they have that same base of 3x plus 2, and then we're going to take the smaller exponent, which would be to the 6th. So part of my GCF would be 3x plus 2 to the 6th. Now, going back to my first group again, we already took care of the 45, we took care of the 3x plus 2 to the 7th, so now I'm looking at that 5x plus 1 to the 8th. Moving over to my next group, I can see that there's also a 5x plus 1, but that one's to the 9th power. Again, taking the smaller of the two exponents, that means for your greatest common factor, we're going to have 5x plus 1 to the 8th. So your greatest common factor of just your numerator is 3 times 3x plus 2 to the 6th times 5x plus 1 to the 8th. We're not going to worry about the denominator right now. So our next step then is to factor out that greatest common factor in the numerator. So I'm going to note this as side work because it should be done in your head, but I want you to see what's happening. So I'm only taking out the numerator, so it's side work because it's not part of our equation. And what I'm going to show is the dividing out of that greatest common factor of 3x plus 2 to the 6th times 5x plus 1 to the 8th. And I'm going to divide that by each group to illustrate how it's factoring out and what our remainder would be. So right now this is just side work. You should be able to do it in your head, but if you need to, just do the work off to the side. So I'm dividing the first group by our greatest common factor, which is 3x plus 2 to the 6th, and then 5x plus 1 to the 8th. I'm going to be doing the same thing by our second group, so 3 times 3x plus 2 to the 6th, and then 5x plus 1 to the 8th. So again, that's going to be part of my factored form. So I'm going to have that 3 times 3x plus 2 to the 6th times 5x plus 1 to the 8th. And then whatever we get after we divide out is going to be what's inside that square bracket. All right, so then simplifying the first group, 45 divided by 3, we can reduce that to just 15. So I'm going to have a 15 inside here. 3x plus 2 to the 7th and 3x plus 2 to the 6th. This will end up canceling out and subtracting your exponents since they have the same base. You're just going to be left with a 3x plus 2, and then 5x plus 1 to the 8th and 5x plus 1 to the 8th will cancel out completely. In our next group, I should have mentioned this before, but you'll see what I did was I reversed the order of the 3x plus 2 to the 6th and the 5x plus 1 to the 9th just to make it easier to visualize how they line up with each other. Since it's multiplication, you can reverse the order since multiplication is commutative, in case you were confused. Okay, so 21 divided by 3, reducing that, we're just going to end up getting 7. Then the 3x plus 2 to the 6th and the 3x plus 2 to the 6 will end up canceling out. are 5x plus 1 to the 9th and 5x plus 1 to the 8th. They have the same base at 5x plus 1, so you subtract your exponents, so we're just going to be left with 9 minus 8 is 1. We're just left with a 5x plus 1. So that would be what our numerator would look like. So that's what we're left with. So I'm going to now get rid of that side work part and jump and say, okay, if that is our numerator, then we can now fill in our denominator that we had from before of the 3x plus 2 to the 14th. So right now we have 3 times 3x plus 2 to the 6th times 5x plus 1 to the 8th, which was our greatest common factor, times what we got after we factored out the numerator, 15 times 3x plus 2 minus 7 times 5x plus 1, all over 3x plus 2 to the 14th. Because now our next step then is to simplify the numerator. So I'll start that here. So we're going to keep the 3 times 3x plus 2 to the 6th and the 5x plus 1 to the 8th. But we're just simplifying inside the square brackets. So distributing the 15, we're going to get 45x plus 30. Distributing that negative 7 becomes a negative 35x minus 7, all over our denominator of 3x plus 2 to the 14th. So continuing to simplify the numerator then inside the square brackets, we're going to keep the 3 times 3x plus 2 to the 6th and the 5x plus 1 to the 8th. But inside combining like terms, 45x minus 35x would end up being just 10x. And then 30 minus 7 would be 23. So that gives us a simplified form of the numerator over 3x plus 2 to the 14th. So in the last example that we did, we would have been done. But now that we have a denominator, we actually need to simplify the quotient by dividing out the common factor, because what we can see here is that I have a 3x plus 2 in the numerator as a factor, and I have a 3x plus 2 in the denominator as a factor. So we can now reduce that. So 3x plus 2 to the 6th and 3x plus 2 to the 14th, we can reduce that by dividing, because remember when you divide, you subtract your exponents. So 6 minus 14 would be a negative 8, but a negative 8 would move it back down to the denominator. Or you could subtract your exponents as 14 minus 6, which would be 8, and then just leave it where the larger exponent is. So I can reduce 3x plus 2 to the 6th and 3x plus 2 to the 14th, and what that does just give us a power of 8 in the denominator. So our fully simplified form by factoring would be the 3. Now that 3x plus 2 to the 6th disappeared, or cancel it out with the denominator. So 3 times 5x plus 1 to the 8th times 10x plus 23, all over our new denominator of 3x plus 2 to the 8th. So this is your final answer. So lots of simplifying.